Hello, my name is Ross Howell. I'm the Managing Director of Quickgrind. I am very pleased that you have joined us for this event, which is being held at our factory here in Tewkesbury, England. We have based this live event in our technical centre where we are machining a very nice component designed and programmed by one of our partners, SolidCam. As a live event, you'll be able to ask questions to ourselves and any of our participating partners. We do encourage you to get involved. Shortly, I will hand you over to two of our team members, Mike and Graham, who will be hosting the event. But first, I would just like to say, over the past few years, we have invested heavily in terms of both latest modern machinery, skilled staff, which has helped us further grow our reputation for the highest quality cutting tools and services, not only in the UK, but worldwide. A major part of this investment was setting up our technical centre, which you will see today enables us to not only test and improve our own products, but also optimise machining for your components. We are very proud of our staff and facilities here, and we do encourage our customers to visit and gain first-hand knowledge of what makes us a world-beating UK company. So I'll now hand you over to the guys and hope you enjoy the event, and please don't forget, ask questions. Over to you, Mike and Graham.
Well, thank you, Ross. As Ross has said, this is the live event at the Technical Centre at Tewkesbury, part of the Quickgrind factory. We hope you enjoy the event. My name is Mike Stobart. I'm the Technical Support Manager for the UK. After I've done my little bit about Quickgrind and where we are, I'll be handing over to my colleague Graham Hawke, who will introduce infinite possibilities, as you can see plastered behind us. It's a very important part of our company and what we can offer. So Quickgrind has been a 50-plus year company. We specialise in producing solid carbide cutters for particular applications. Within the last 2 years or more, we've spent over £2 million investment in new machinery. So we have the latest Anchor software, Anchor grinding machines with laser check-in, to the extent that now we say in a batch of 50 to 100 tools, we're producing within 1 or 2 microns tolerance, which is, I think, will be very good. Something very important that we'd like to get over today is that seeing is believing. We're very proud of this factory. It's grown up over the last 7-8 years. It's how it's changed, and we invite people to come and see us. We think that's vital, really, for people to understand what it is about Quickgrind and the recipe that we put into the cutting tools. So I think I could go on forever about that, but what we'll do now, we'll hand over to Graham, and he'll talk about the infinite possibilities, and hopefully you'll understand where we're coming from. Graham.
Thank you very much, Mike. Hi, my name's Graham Hogg. I'm the Technical Support Manager for Quickgrind, and as Mike's just been saying, one of our main moves is infinite possibilities. Basically, infinite possibilities is what it says on the tin. In the realms of solid carbide and round shank manufacturing, Quickgrind like to believe that we can manufacture almost any form, flute length, geometry that the customer requires. We're not a catalogue driven company. We do have a few standard ranges, but what we tend to do is speak to the customer directly and find out what their requirements are, and come up with solutions. All too often, on a day-to-day basis, people talk to me and they buy out of a catalogue, so they're just compromising instead of using a cutter and customising. What we like to look at is putting the right cutter for the right application with the right geometry and get it right first time. So in effect, you could customise a whole component. The advantage of that is you optimise the component to its nth degree, and you're producing the part faster, you're producing it more accurately, and you're ending up with a better solution all round. What we do is, again, we have a little slogan between us when we're out there on the road, and we say, why compromise when you can customise? And we like to go along with that. We build a relationship with the customer or client, and we take it along as far as that as we can go, and that gives us the harmony with the customer, and we can also produce the right cutter, as I was saying earlier on. But we'll talk more about infinite possibilities as we go on, because it will get laced in throughout the whole of this event. So we're now going to go over to a solid cam demonstration on iMachining, and you'll hear the voice of Ben Miller from Solid Cam explaining what iMachining is all about. Okay, thank you very much for joining us. Cheers.
So we're first going to have a look at a presentation of SolidCam. We're going to have a look at the features and benefits of SolidCam, and we're also going to have a demonstration inside the software as well of the part that's been programmed for today's seminar, how it's been programmed, and then we will cut back to the cameras in the machine to have a look at this being cut live. Our iMachining module, so this is our high-speed roughing operation inside SolidCam with a technology wizard built in as well. So we get increased productivity due to shorter cycle times, up to 70% and more cycle time saving. We dramatically increase the tool life and unmatched hard material machining as well. We see outstanding performance when using small tools, and we can use iMachining on 4-axis machines, 5-axis machines, mill turn machines as well. High programming productivity and a very short learning curve. The unique wizard will optimize the feeds and speeds for you, including the depth of cut based on the stock and the tool material, as well as the machine specifications. So this takes the headache out of programming these high-speed roughing operations. So iMachining comes in 2 stages, all built into the same operation. The first stage of iMachining is to create an intelligent toolpath, so an efficient tangential toolpath which will ensure constant tool load on the machine. And then the second part of iMachining is the technology wizard. This will calculate the cutting conditions for any given machining operation. So this will calculate things like the speed, the feed, the depth of cut, and also the cutting angles. So we can have variable cutting angles. You can see there from 80 degrees to 10 degrees we can have set the maximum and minimum cutting angles based on what we wish to achieve, or we can let the wizard handle those maximum and minimum based on the material parameters that it's been given. You can see there on the left hand side at 20 degree engagement the feed rate is a lot higher than it is on the right hand side at 50 degree engagement. So iMachining will fluctuate the feed rate based on its engagement and its contact points as well. iMachining is a patented technology. No other system can use our technology. You may see other systems using the spiral or morphing toolpaths, but you won't see any system using a spiral toolpath and also calculating the speeds and feeds and depths of cut using our technology. So let's have a look at a demonstration of the component that we're actually cutting live on the machine today. So as we can see, this is the component in SolidCam, and we first want to do some 3D iMachining in this orientation here. The tool we're using is the 12mm end mill in this particular operation, and we've defined the helix angle and the tool material in the iData. If we look at the technology wizard, you can see it's nice and green, so the ACP is close to a whole number. This means we should get no vibration, and you can see if I use the machining level, it will adjust the speeds and feeds and the step over accordingly. If I look at view 2 as well, we can see the meters a minute, 183 meters a minute, and the chip thickness of 0.08. And I've also chosen to do some retrofitting, leaving a 0.3 scallop. Now if we see this in simulation, you can see iMachining going round there and machining all the material off. It's 3D iMachining, so it's taking into account the 3D shape and leaving that 0.1 scallop on there. And we can see this here against the actual cutting. We can see it machining out all of that pocket in the center of the component there. Now with iMachining as well, it aims not to leave any thin walls, so we call this islands. So you can see here it machining through a section of the wall, and then it will go and machine through another section of the wall to leave what we call an island in the middle, and then it will machine all the way around that island to reach the center, so that we're not leaving any thin walls and not machining up to any thin walls that could cause the cutter to break or any swarf to snag in there.
Thank you, Ben. Thank you, that's very good. So the next slide you're going to see is the tools that we're using today, and you can hear spinning away at the moment. One of the important tools that we're going to show, and all these tools will show some details in much later, but is the tangential barrel tool. It's a new development for us again. It's manufactured for the job. We will talk more about that when we get onto the actual eliminator barrel tool range.
Well, eliminator,
right? Yeah.
Easier for you to say.
Yeah. And also, you know, it's a finishing tool which gives incredible finishes, great step down. So we'll explain that later. We're also showing a lens tool. Again, it's another finishing tool with a radius on the bottom. This is a 12.5 radius with 3 flutes, 10mm tool, as you can see. Now, roughing out, we're using our Q-cut range, and in a minute Graham's going to talk to you about the Q-cuts, which are available in lots of different versions, of course, as we've already said, through infinite possibilities. And we're using a ball nose, you know, certain parts. You know, we always like to use a barrel tool or a lens tool, but certain features do require ball noses, and we're very good at making these ball noses. So I think over to you, Graham, on the Q-cuts.
Yeah. Hi, before I talk about the Q-cuts, we've got our first question, and there's a question from John, and he says, could Graham please start talking in English, please? We can't understand a word he's saying. That's a bit harsh, Mike, I find. That's a bit harsh. Anyway, Q-cuts, yes, it's a range of steel cutting cutters. Once again, you know, we do have a standard range of Q-cuts, but if you want it a bit longer, a bit shorter, 4 flute, 5 flute, maybe even onto 6 flute, we can do that. The geometry of the Q-cut is a variable helix cutter, variable pitch as well. It's a fantastic cutter, and the majority of steels, and some of our customers actually even push it into the stainless steel realms with success as well, more on the free machining side of things. As you can hear it at the moment, it's whizzing away in the background. We do very, very well with them, and it comes in a TILN coating on it as well. And like every other cutter that we do in my range, and going back to the infinite possibilities, we can put a rad on it, any specification you want. We can also make them an imperial, like I said about flute length. We can neck them back as well if you're doing long walls. Once again, it's very, very advantageous when it works in unison with the iMachining from SolidCam, because it's just absolutely purpose made for that type of machining. The swarf evacuation, the swarf form, that IE machining produces is absolutely fantastic. So I'll put you back over to Mike to talk a wee bit more about the rest of the cutters that we're using today, and enlighten a wee bit, and we'll bounce back off each other as we go along. So over to you again, Mike. Thank you.
Thanks, Graham. So I think as well, on the Q-Cut range, it's a high performance tool. We get the recipe right for each application, rather than just running from a catalogue. We'd rather go to what do you want, what are you trying to achieve, what is in it that you can't achieve at the moment with the current suppliers, or even our own tools, because with constant development is how we like to push forward. Chip breaking tools with a lot of eye machining, producing a lot of long swaths. It can be a problem at times for clearance, so obviously chip breakers, and we design the chip breakers for the job as well. So it's not just here's a chip breaker. We look at what you need, what you're trying to achieve, and we'll do it for you, and we'll work with you to make that work. I think really what we should concentrate on here is the fact that this is a truly high performance tool. We show it on the slide, steel cutters with an edge, and the edge is we make it to suit your application.
Absolutely.
It's not just the cutting edge which is important. It's giving us an edge and you an edge for to win over new business. And I think as well, so we should state here. You can see on the slide Q Plus. Q Plus is a very much a go-to range with a longer flute design, sort of as a standard, if you like. It's a variable pitch. It's a lower priced economy range. So don't be put off with the fact that you think there's only one steel cutter we do. You name it, we'll do it, and we love people to throw problems at us. Really, we don't make our lives any easier by we'll just supply that little tool. We go for it as we need to. So anything else we need to say?
No, just you bringing in the Q plus here, because I forgot to say it. Sorry. So well done, Mike. That's why we work so well together. Help each other out every time. But it's a very good cutter. It's a very economical cutter, and again, as Mike was saying, we can do it in chip breaker form to once again give you a better swath removal and swath evacuation, which is very important, especially if you're dry machining and you want to stop the swath layering up. Also in the range today, I think Mike might have mentioned it earlier, and we'll talk about it more as we move on. The high feed cutters are being used as well, and we find these very, very helpful. And along in the realms of the eye machining and high feed cutting, this takes you into a range of being able to use lower powered machines to produce big pockets, because you're not doing big step overs and really having to labour the cutter and tax it, and obviously your load meters are going up. When you're in this high feed machining, you're using far less load on the machine, so it opens the whole machine shop up. Some smaller machine shops can produce from a 20mm slot up to a 80mm slot using the same cutter, because you're using different strategies as opposed to having to start going on to heavier cuts and stuff. So that's where we throw our technology into it, and that's where we're forever expanding. The Q cut, and like every other cutter in our range, will only get better, because the reason why there's tech centres here is because we're constantly innovating and constantly developing our cutters. We've got the technical support guys on the road, and we've got the applications engineers in here, John and Charlie, and they're constantly got their heads down, and they're trying new methods, trying new strategies, the speeds and feeds, different data we're collating all the time. So we're on the go all the time. And Quickgrind today is different tomorrow and different the next day, and we're improving the cutters, and the end result is that the customer is constantly getting improvement as well. So when we work together like that and we're communicating with the customer all the time, the situation is that you're getting a better product every time. You're probably going to get it quicker every time as you develop your process, and everybody's happy. Everybody's in the same same singing from the same hymn sheet. So it's a great route to take. It's a great journey to go on with us. So like I say, give us a go in infinite possibilities. You know, you just have to pick up the phone and speak to us. Anything else to say, Mike?
I'm thinking more on the fact that what's going on in the tech centre now and our partners here. So what's important for us here is the people that you associate with that give you the best chance to achieve the goals that you're setting out to achieve. So obviously this tech centre can't stand alone. We need the best machinery and the best partners for tool holding and clamping, lubrication, etc.
Aye. Mike's just mentioned there, you know, the partners within the centre, and one of the partners that we have is a very, very important partner to, and as you can see in the background here with the Mazak J500, is Mazak. A couple of weeks ago I caught up with Brian Edmondson from Mazak, who spoke to me at length about what Mazak are doing, what's going on in the future. So now we're going to go over to an interview that I did with Brian, and so I hope you enjoy it, and we'll get back to you soon.
Good afternoon, Brian, and welcome to Quickgrind's live event.
Afternoon, Graham. Thanks for having us.
As you know, Mazak and Quickgrind have got a very good working relationship, partnership. It's been ongoing for several years now, and to the extent that we now have the tech centre, which is just recently opened within the last year, and with the Mazak J500 situated in the tech centre, which has been excellent for us. You know, we've done several demos on it and days like this with people actually there. Just to expand on that a bit, typically what type of customer would you be putting the J500 out to?
Well, Mazak supply quite a diverse range of customers, so it's important to us that we can supply the right solution, because typically our customers come to us for a solution. So we have the I-Series range, which is the all singing, all dancing, full 5-axis, with lots of different options that you can add on to it. Then the J-Series was more of a first step into 5-axis. It's more of an entry-level 5-axis machine. But as technology's advanced and things have developed, then it's become more of an intermediate 5-axis machine. So what we've recently done is we've superseded that, the J-Series range, with the new C600, which is a machine that's built in Japan, which consolidates two machines but gives the larger working envelope. So that was going to be 730 diameter by 450 high. So it's a very generous working envelope.
Yeah, definitely.
That's going to be quite a commercially driven machine as well, but it is built in Japan, and that's going to be more of an intermediate 5-axis machine, which is where the J500 ended up being. As technology moved on, it went more from being entry level to being an intermediate level 5-axis machine, much more capable, fully simultaneous. So that's kind of where we've gone with that machine. But there's a lot more options on the C600, because the more options the better for us to provide the solutions that are going to suit our customers' needs.
So reading into the what you're saying, Brian, the C600 will replace the J500, and the J500 will be gone completely out of your range?
That's right.
Yeah.
So what we're going to do is we've developed the CV5 500, which is a compact vertical 5-axis machine, which we're building and developing in the UK. So we're building that in Worcester, designed and fully manufactured here in Worcester, and that's going to be the entry-level type 5-axis that helps a lot of customers get on the ladder. I mean, to really answer the first question, the types of customers that we supply to is quite varied. So the J500, for instance, we supplied into small subcontractors and people replacing an old 3-axis machine for something with higher specification or a more capable solution. But then we've also supplied it into well-established aerospace customers. So it's been a good all-rounder, which is where the C600 is going to be, and where the CV5 500 is going to be as well. So there's more options with the CV5 than we have with the J500.
All right.
So
yeah.
More bigger tool magazines, we can have multi-pallet solutions, more so with the CV5 500 machine, because we've designed this in a way that it's it's ready for automation, because we're seeing more of a drive towards automation. Certainly in recent times, people are more open to those lines of conversation. And what we've done with the CV5 is, rather than have the typical Trunnion style 5-axis where you open the door and you're looking at the A-axis, we've turned that 90 degrees so it's a B-axis, which allows us to side load a multi-pallet solution right through the side of the machine, but it also allows you to use it as a normal type 5-axis if you want to use it with an operator. So sometimes with when you add the automation, the robot sits in front of the machine and it becomes difficult for the operator to gain access. If it's on the side, it's just much more ergonomic.
Excellent. So the C500 is now going to be a more powerful, potent entry-level machine, replacing the J500. Just to expand it, you've got the C600, you've got the C500. Do all these machines get built in the UK, or some built in Japan, some built in the UK, or how do you split that?
Well, the J series was built in Japan, as is the I series 5-axis machine. So the C600 that supersedes the J500 is built in Japan still. But the CV5, we've designed and we've developed that machine in the UK, and it's fully manufactured here. So we're not building that in any other factory. The CV5 500 5-axis machine is built here in Worcester, and it's a fully UK engineered solution. They all come with the smooth control. So we've got the latest generation control technology there, which is fully conversant with ISO, but also has the conversational aspect to it as well. And that has a lot of performance advantages, which allows you to really optimize your machining process. So you can set the machine up into high speed mode or high accuracy mode, or if you're chasing a particular surface finish, you can really configure the machine so it's suitable for your application.
Yeah, excellent stuff. So you're flying the flag for Mazak building manufacturing in this country. That's very good to hear. It's always nice to hear that they're
doing our part. Yes.
We're talking about the smooth system. You know, it's a fantastic system. Obviously, we've got on the J500 down at the tech centre. Is there any new wee cheeky parts getting added to it? What's the latest on that?
Yeah, well, we've got some latest enhancements coming on the new line of technology. So we've got AI is the future, and artificial intelligence, and we've got an AI control now which links into a lot of Industry 4 type technology. So companies are more interested now in how the machines are operating, so you've got more visibility on what the machine's doing. So you can you can really interrogate and collect that data and then do something with it and present it in a way that is manageable, which we've done for a lot of years, but Industry 4 is now the banner that all those things fall within. But then we have an AI spindle, which this is very good technology, which allows us to automatically tune out any vibrations that's detected whilst you're cutting materials. So once you start to detect the vibration, the machine can alter the cutting parameters to tune that out very, very quickly. So rather than old school, you would hear the right pitch for a milling cutter on metal. This automatically means that you don't need to start playing with the speeds and feeds because the machine
very interesting.
Will do it for you.
Excellent.
We've also got some further enhancements to the thermal control, basically the variations in temperature. So we've got more sensors, which allows us to keep a higher level of accuracy. So that's the AI thermal temperature control. But yeah, you're right. It is interesting, and it really helps us keep up with the rest of the technology that all our partners are also pushing the boundaries, whether it's the cam, or it's the tooling, it's the whole package. The machine needs to be able to be capable of keeping up to date.
Very good.
Just on the smooth control.
And from Mazak UK, if anybody's looking to visit you, come to the facility, look at a machine tool, go around the showroom, are you open now? Are you welcoming people in, and how do we go about it?
Yeah, I mean, we are open. Now we're having visitors in. We do the normal COVID forms, which most companies are doing, but we are implying social distancing. We are still taking customers around the shop floor. We've got a one-way system introduced, so it is very safe. I'm very confident to have customers here. We've got large meeting rooms, and we're just adapting to the new normality, really, Graham. But it's working well. So we are an open door. We can just buy an appointment, and then we can show you everything that you want to see at Mazak.
Well, Brian, that was absolutely superb, and thank you for enlightening us on where Mazak are heading towards. Thank you very much for attending today and giving up your valuable time. And maybe in the not too distant future, we'll be coming to you for a super deal on the new C500, and we can trade in the old J500. You reckon?
I hope so. Yeah, thank you for the opportunity.
But thank you very much for joining us. It's been great to see you. Hopefully I'll see you face to face at some point soon, and take care.
Thanks, Graham. You too.
Thank you, Brian. Very, very good again.
Yeah, thank you.
We've had a question come in. Thank you very much. That's the idea of this, you know. Throw the question in to us, make our job even harder. We're not worried, are we? About the Q cuts, can we do 8 flutes? So yes, of course you can do an 8 flute Q cut, but what we have is another range of tools which isn't showing here today, called our Demon. The Demon are specifically designed for finishing operations in all sorts of steels, particularly die steels. Tremendous results from that. We make them all of various different lengths. So again, Demon, think about infinite possibilities. What are you trying to achieve? So, yep, Steve, you can get 8 flutes. Now contact us afterwards and tell us what you're trying to achieve, and we'll discuss it with you. So I look forward to that. So, okay, you've had
I've got another question, Mike. Yeah.
Cool.
Yeah.
Go for it.
I've got another question asking, you know, from someone that's saying that they've not really heard much about Quickgrind, and I suppose it leads on to the size of the company, because they're asking what sort of quantities can we produce. Well, the simple answer to that is thousands. If you want 1,000 off, we will produce 1,000 off. We'll produce 5,000 off, 10,000 off, and we'll do it quickly, just like another thing it says on the tin. That's why we're called Quickgrind. You probably can't see if we were sitting, but we have a partition wall here in the tech centre. The other side of the partition wall is our manufacturing plant, and we have 30 plus multi-axis CNC state-of-the-art grinders. So the numbers are no object to us. Likewise, we'll produce a 5 off, and a 5 off quality-wise and accuracy-wise will be every bit as good as a 10,000 off. So yeah, we like big numbers, so get in touch with us.
And don't forget, Graham, they can always send it back to us in those quantities for remanufacture, which we're going to talk about later on.
Absolutely. We're a good team, us two.
Yeah,
We work well together.
Well, I'm going to forget something for you, Dave.
Now, moving on from the Q-cut questions, which keep them coming in, we're going to start talking about the Mirage range, which is the next step up. The Mirage range is for the stainless steels and above. Your exotic materials, Inconels 91X, Hastelloys, Super Duplex, Haynes, titaniums. It covers a vast range, cobalt chromes, that sort of cutter. Again, you know, the infinite possibilities comes into it, because whatever you require, we shall manufacture in the Mirage geometry. And likewise, so Michael elaborate onto it a bit more, whatever flute is required. But once again, we'll want to speak to you about that, because we might tell you more flutes or tell you less flutes, depending on what our technical ability and what we reckon is going to be the best solution for what you're trying to produce. So Michael, I'll tell you a bit more about the Mirage cutters, and they'll probably pop back to me in a minute or two. So over to you, Mike.
Thank you, Graham. So the Mirage was one of our flagship cutter that when I joined this company 7.5 years ago, can't believe the time, I tell you, yeah. It was the main tool that we needed to get going in, shall I say, in the UK. I mean, we're a worldwide company. You know, we supply to 37 different countries around the world. What we need to do is get get better known in the UK, and I think we've done that very well in the last few years.
Very
We've
good.
got now 4 people out on the road, technically capable people, and the applications people is here. So what we've got is the Mirage, like Graham was saying, is for super alloys, stainless steels, especially any of those super alloys. We don't need to go into all the different variations, but and what we'll do is, again, we'll produce. If you just want a standard catalogue of 12mm, 26mm flute, 64 overall, we'll do that for you. But if you say, I want that with only 12mm flute and a R1, or 32mm flute, because I want to, rather than stepping down three steps to achieve the depth, I want to do it in one depth. So, okay, iMachining can help you to do that. So the Mirage really it's been a very successful tool for us. People ask us, I need a tool 150mm long, 50mm flute. Yeah, when can I have it? Okay, we'll draw it for you. We get the CAM software sorted out. Go to drawing, send off to you, fully ISO specification. You sign it off or make the alterations. We send it back. It's logged in. Then we discuss the price, and you can order that if you like to. We're quite happy to get orders, aren't we? Yeah. Something like that. Basically a minimum 5 off. You can. You talk to us. We'll sort out what you need. We'll run it, and we won't just leave it there. We'll then say to you, are you happy? Are you achieving what you want to achieve? And if we'll even say we can get that back. We'll look at the wear. We can come up with change geometry. Really simple for us to do. For us, a lot of people say that's a special. It's not. For us, it's a tool. We'll make it. You want it, we'll make it. I'm going to throw you into the ring now, Graham, and you can talk about Mirage Super.
Well, the Mirage Super is, we're not going to tell you what the carbide is because that's top secret, and if I did tell you, we'd have to come and kill you. And it's also got our latest coating on it as well, and likewise, I'm not going to say too much about that, but the combination of the two takes us up in the next realms where you're already high-end machining and high-feed machining. You can go that bit quicker. Obviously, it comes with a cost because it's more of a problematical manufacturing process for us in the sense that it's a tougher carbide. But as I said earlier on, we're forever advancing within this company. And we've come up with the Mirage Super to compete with the ever-expanding range that our customers are coming out with in the market. We like to think that the Mirage Super now is a cutter that's up there at the top, if not amongst the best. And we've got no fear about taking it into any customer and showing what it's all about, because we're having some fantastic success with it. Whatever flute variation it is. And just on the subject of that, when we're talking about the Mirage geometry, we talk about Mirage geometry, we talk about Q-cut geometry. There is differences, but they're sort of generic to the process, because if we're making an out-and-out special cutter, like a Woodruff cutter or a T-slot cutter, we take the geometry of the Mirage cutter and apply that to that type of cutter. So you're not only getting a T-slot cutter where most of the cutters out there in the big wide world, it's a T-slot cutter. It's pretty basic. We apply that geometry within the cutter, so you're actually getting cutters that are not just you're having to slow everything down. You're getting a cutter that's got process behind it. You've got a cutter that's got performance behind it as well, and the customer loves it with that. So we don't only just put that type of geometry, the Mirage geometry, onto our fluted cutters. We apply it to everything that comes in to those realms of exotic machining. And the next thing we're moving on for that, we've got the aluminium range. We do predominantly 3 cutters in the aluminium range. We've got the Alligator Duo, the Alligator Trio, Duo being a 2-flute, Trio being a 3-flute, not trying to teach you how to suck eggs. And then we have the high performance Cayman, which we're getting absolutely fantastic success with. And once again, like we maybe sound like a stuck record, but we do want to emphasise about the infinite possibilities. You can have any shape, form. We also have a range, within this range we have a ball nose as well. They've got a snappy name, alligators and caiman. You probably figured out, you know, where we're going with that. But they don't behave like that. They don't snap. They last too long. That's our problem. But I've spoken enough at the moment, and I'm beginning to dry up, so I'll be back over to the mic for a minute.
Do you want to sip with my bottle of water then? Oh no, we can't. COVID, you're not allowed to.
No.
Again, yeah, so thanks. Thanks.
I think I'm looking at the camera here. I should be.
I just realised I've just used your nickname then. Apparently, yeah.
That's all right.
If ever you meet this guy, you know, his name's Graham Hogg, and everyone calls him Hoggy. So
yeah, Hoggy will do it.
Yeah. So again, yeah, 2 flute, as Graham was saying, 2 flute, aluminium cutter, very thin primary. The idea with that, you know, aluminium does. Everyone says, "Oh, just cut an aluminium." Yeah, fine, but you know, we want a tool that's going to last. It's not going to break. If it's out of a size that can be remanufactured, that's what we want to do. Same with the 3 flute, and well, just any of our tools. You know, we always make every tool with a view for it to be sent back to us for remanufacture. And that, you know, you're not just buying a tool. Then you're buying a whole cycle of, I say, economy tooling. Okay, we're chatting on too long. Graham's now going to introduce the next partner.
Yes. Yeah, we've been a busy boy out there, trading the boards, and I caught up with Gary Williamson from Nicken, who very kindly sat down for a considerable period of time and discussed about the quality of Nicken. We've got Nicken holders that have been used in the machine at the moment. Gary will embark on a bit more. We use Nicken because they're absolutely fantastic quality, and it gives us a rounded package, because what we like to do is keep a consistency throughout our process. So if we're using a good tool holder, we're going to get a good result with our tools, and that's why we go down the Nicken route. So over to the interview with Gary Williamson. Thank you.
Good afternoon, Gary, and thank you very much for giving up your valuable time and joining us on the Quickgrind live cutting event.
Thank you, Graham. Yeah, very much looking forward to being involved in this year's Quickgrind live events, and I'm sure it will be very successful too.
It's the relationship between Quickgrind and Nicken has developed over the years, and we have a fantastic partnership. You support us immensely well down at the Tech Centre, but it's your stage today, Gary. Tell us what you're bringing to the table today, anything new with Nicken, and what's current, and what you're actually going to be putting into the event today. Thank you.
Yeah. Well, the problems that we were approached with from yourself was access. I think you do a simultaneous 5-axis component, and there's 2 products within our portfolio really that solve the access issue. The first one being, fortunate for us, that we've got a new range of shrink tools available to market. Quite a heavy investment this year of around 4,000 pieces of shrink tools to fit our portfolio. The shrink tools we've got are 100% ground, obviously 3 micron accuracy as standard, and a full range going from 3 to 25 millimeter in lengths of up to 200 off the shelf with cooling options. So one of the tool holders is one of our 6 millimeter shrinks for accessing for the barrel cutting, and the other area, as you know, Nicken predominantly is a focus on mechanical chucking systems, and the reason we focus on that is because you get a greater cutting tool retention, greater gripping force with a mechanical system. So the other tools, the other 3 tools that are on demonstration at your event is going to be the mini chuck. It's the mini advanced alpha, our very latest mini. It's the 8 millimeter capacity holders, and you know those mechanical systems typically give 3 times the gripping force of conventional machine tools. So great for difficult processes where you're taking probably heavier cuts, and it works on a drawbar system. As you know, the collet is a screw thing at the back and is drawn back into the body of the holder by a screw thread. So that means there's no nut on the front of the jug. So access is excellent on an 8mm capacity. We're down to 20mm, so you can get right up to the walls of some of these components. And the collet, being a long series collet, is gripping at the nose as well. So you get really good engagement of the cutter shank with the mini advance. So those are the 2 products we're demonstrating with your cutting tools on that 5-axis process on the event, and it's access, accuracy, gripping force to allow your cutting tool really to run 100% of its capability throughout that process.
Excellent, Gary. That covers it very nicely, and it's I have seen in some of the releases that you've done about the shrink fit system, and it's interesting to see, and thank you very much for involving that in the live event today. We've all been coming through very hard times. Where is Nicking at the moment? Is the doors open at Nicking World and are people allowed to come in?
Yeah, very much so. The doors are open. We've, as you know, at our innovation centre on the Advanced Manufacturing Park in Sheffield, we've got our 9 machines there, from a small 30 table machine to a heavy duty 100 HSK 100 and BT 50. We do our own testing and development and offline programming. We do process optimization here, first artifact machining. But yeah, we're able to demonstrate our products on a variety of platforms that are available to us, including the things like the presetters. We've got the full range of presetters on demonstration here from our, I say entry level 3, 4, 6, but the entry level really for us has got vacuum clamping and it's network capable with auto measure functions, going up to the top end presetters, which obviously have things like tool inspection, 40 times, 60 times magnification, not just 1 camera but 3 cameras for top, rear and front inspection and measurement. And also the tool management system. We've got our own TP32 tool data management system for inventory control and tool management. So we can link all those together and give a very good, interesting demonstration to customers here, which we are doing. We've seen an increase in numbers of people, visitors coming through the doors now, so it's getting a little bit busier, and I think that's the way we like to promote our product, is by demonstrating like you are doing at your event, in fairness. And then within the Innovation Centre, obviously we have an array of angle heads and rotor tables. You know, your machine is a dedicated 5-axis, which we have here. But we retrofit our own 4th axis, 5th axis units to our own 3-axis machines to give either 4-axis trunnion setups or full 5-axis retrofittable solutions to the vertical machining centres that we've got on demonstration. So yeah, we've got a lot going off here at the moment, and you know, with the investment that we've made in the presetters and things like the shrink tools, we're hopeful to get busier as time goes on.
Excellent, Gary. That seems to have covered everything, and once again I'd like to thank you very, very much for joining us this afternoon. Your support is fantastic to us, and long may it continue, and we love working with Quickgrind, and long may that continue. Thank you very much for joining us this afternoon.
All right, thank you, Graham.
Hi, and welcome back, and thank you very much to Gary Williamson for that excellent interview. Before I hand over to Mike, we have another question that's come in from one of our viewers, and the question is, do the Mirage cutters have polished flutes? Well, yes they do, is the answer, as does the Mirage Super. But we, such as the quality of our grinding and the quality control that we maintain, the flutes are pretty much coming out polished because of the way that we maintain the wheels, the way that we dress the wheels, and the process that we have in place about dressing the wheels, because it is a very, very strict process that we run throughout the factory. If you couple the polished flutes with the X-Red coating that we do and the X-Red plus SL coating that we do, it's probably, until you get onto DLCs, the hardest coating that's out there in the market. And the beauty about the X-Red coating as well is it has a very, very low coefficient of friction, which means any swath coming off, material removal, heat is dissipated out through the swath, so it's slipping off the flute all the time. So we have a bit of a double whammy there. We have a highly ground finish, which is polished, and then on top of that we put the X-Red coating, so the surface is absolutely pretty much slip free. So hopefully that answers your question. But if you like to put the proof in the pudding, get out there and get in touch with us and try some. Thank you very much. Over to Mike.
Thank you, Graham. Yeah. So the next slide, we're talking about our high high feed tools. So high feed, as you see on the slide there, we do 4 different versions. We love our names at Quickgrind. So we've got Spectre. It's probably quite a good tool to talk about this time of year. Coming up, we're going to machine some pumpkins and put it out there. Spectre, Phantom, Bulldog, Reaper. I'll talk about the Spectre. Spectre is a development which came about from a particular need that a client had for deep hole pocketing, struggling with to get to really produce it to the degree that they needed to in titanium. So the Spectre is a radius tool, 3 flute, mainly 3 flute. We have got some 5 flute funny enough coming up. Now, X-ray coating, the recipe on the tool is designed that the tool won't break. Of course, someone's going to prove me wrong now, but the tool won't break. But we want it back to make sure that you get the best from the tool. So we'll design the tool short, long, whatever you want. We've got some 2mm with 40mm necks that are doing some very filigree work on some dies. We've got 12mm through coolant that are doing tremendous work in titaniums. So it's a kind of tool that you can use. Once you've got it in the shop, you suddenly go, oh, can I use that? And it becomes a bit of a favourite. So high feed means higher speed, but also higher feed with shallower depth of cut, but the metal removal rate and the time savings are tremendous. I think Graham's now going to talk about the Phantom.
Yes, the Phantom is our 4 flute high feed cutter. It's got a completely different base geometry to the Spectre, and I mean, quite simply, it does. It's a high feed machine, and it's a very small step down, very high feed rates. The applications that you can throw it into for pocketing, for hole drilling, especially into harder materials where drilling can be almost impossible at times, and you apply a high feed cutter with the correct strategy on it. You're producing holes. It's one of the things that we say within Quickgrind, because we've produced so many of these cutters. Why is everybody still using so much drills when they can go down the road of using these high feed cutters? The Phantom cutter, which we'll talk about a bit more in depth in the process, you can remanufacture the Phantom cutter as well. So it's more than a one-hit cutter. When we talk about remanufacture, which I'll not go into in depth right at this moment, it is a remanufacture. It's not just a regrind. There's a lot more in it than that, a lot more science involved in it than that, as with the Bulldogs as well. But we like our names. We have the Spectre and the Phantom, and put one of them in and just watch the material disappear. Ha ha! That's a rubbish joke.
Terrible.
But yes, so that's the Phantom 4 flute, buoyant again on exotic materials. Fantastic results we get on titaniums as well. So many different applications. And I'll pop you back over to Mike now to talk about the Bulldog and the Reaper.
Yeah, so the Bulldog is one of our flagship tools. It was developed a long time ago by the founder of the company, Eddie Howell. It's a tool that is used in the dye industry, aluminium extrusion dye industry tremendously. Generally a 4 flute. We do it's a shortest flute length, and the variations on lengths of tool, lengths of neck that we do are tremendous. You know, when I first joined the company, I tried to get together the kind of ranges that we do, and I gave up because there's just so many variations that we do. It's incredible. So these tools come back to us from all around the world for remanufacture. You're looking at 5, 6, 7, 8, maybe even 9, 10 times, depending on, you know, you take care of the tools, you change them earlier, you get a decent wear of it, you get a very good remanufactured tool back. Now, sort of going on from between the Spectre and the Phantom is where the Reaper came about. I mean, there's this particular 4 flute geometry that between a 6 and 12 mil range for particular die steels. With our trials, we were able to outperform, so say, just about anyone on the market on that one. So there's a challenge for you. John Butler, our application manager, is a big fan of this tool. So the sort of trials he's been able to do on that on various tools, some H13, soft, hard, that kind of thing, tremendous results. So again, we'll design the tool around the application. We've now got to go on to the next screen, which is about ball noses. Over to you, Graham.
Yeah, I mean, it follows the same mould. We have once again in the mould and die industry where we're very, very strong. You know, we do a huge range of different types of balls noses, diameters, lengths to suit each application. And again, we have a aluminium geometry, we have a steel geometry, and we have the stainless stroke exotic geometry. The range that we do, again, you know, I mean, you get 4, 6, 8, 10, 12 millimeter ball nose. You know, if you want a 4.8 millimeter ball nose or a 5.3 millimeter ball nose, an 8.7 millimeter ball nose, you know, we're going to make it for you. And especially if it's going to be in quantity, you're going to get it for the same price as you would for a different type of ball nose. And likewise, again, as we go along with everything that we do, we can do the Imperial range as well. We have fantastic results with all the ball nose that we do. And again, you can have it in whatever length you require and whatever coatings. In particular, when you look at the aluminium geometry, and we've not really touched on it as yet because we've been talking about, you know, the Mirage type range and the coatings on that and what goes onto it. We do a TX coating and a TX plus coating, which on high silicon content materials and castings, you know, when you apply the TX coating onto it, you know, it's a fantastic combination for that type of machining. So there's so much what you can do with throughout the range, and again, I keep saying about, you know, it's infinite possibilities. But I'll stop babbling on about ball nose. You know, it's a good product. It's another fantastic product within the range. So we're now going to go over to an interview I did, I don't know, maybe about a month ago, because I've been doing these things for ages, with Ian Llewellyn from SolidCam. And so it's over to the interview with Ian. So we'll see you soon. Cheers.
Hi Ian, thanks for joining us in this live cutting event.
Hi Graham, thank you very much for inviting us. Good to be with you.
Yes, SolidCam and Quickgrind have done several events together now, but I was wondering if we could talk a little about the software from your point of view. So where do you see SolidCam's strength in the CAM market compared to other available systems?
Well, I think we've got kind of three main areas. Whilst SolidCam is a great CAD/CAM system across the board, I think we've got three elements that make us stand out from other systems. iMachining is probably our flagship product. This is a a system that sets itself up and adjusts the speeds and feeds relative to the tool. So you enter the tool data and the material data, and you know the results that you get of that is a self-adjusting feed rate, which obviously has its benefits. Maybe the second one is Swiss type or sliding head machines. These particular machines are very complex. You know, they take a lot of consideration when you're doing the post-processors, because you've got, you know, possibly up to 13 axes all moving simultaneously. So, you know, you need to make sure that you're watching out for all of those. And probably the third one is one that we've been working with you guys quite closely with, is barrel tooling.
Yeah.
You know, when you come to 5-axis and using barrel tools as opposed to traditional ball noses, there's some massive savings to be had.
Yeah. You mentioned eye machining, Ian. What time saving do you see that eye machining gives you?
We advertise eye machining as being able to save sort of around 70%, and that's quite a conservative estimate, to be honest. Depending on the material type, I mean, high carbon steels, we're definitely looking at 70%, but when you start getting into your stainless steels and getting into your exotics, your Inconels, and then up to titanium and stuff like that, we've seen savings of over 90%. You know, and whilst maybe the initial cost of eye machining looks a little bit expensive, when you start looking at those time savings, you very quickly recoup your money. So it's you know, it's a great product for time saving and money saving.
Right. Okay. And are similar savings comparable to like when you're working with barrel tooling?
Well, yeah. I mean, one of the things that we've found, especially like I say, working with Quickgrind, is being able to do a much bigger step over because of the radius form on the side of the tool. Traditional ball noses, to get a finish, you're probably looking at sort of 0.1, 0.2 you know, maximum step downs. But when you're looking at 10 to 20 times that depth of cut and still achieving you know, minimal cuss pikes and surface finish is where you need it to be. Those time savings again become quite apparent, and you know, barrel tooling isn't massively expensive. You just need the technology to be able to drive it, which is where SolidCam comes in.
Yeah, very good. Earlier on you touched on the sliding heads. How difficult is it supporting Swiss style sliding head machining?
As I kind of said previously, they're notoriously difficult because of the number of axes that you've got to sort of monitor and maintain all the time. Absolutely. So your post-processor needs to be absolutely spot on. And then when you combine that with, we've got simulation within the system as well, that allows us to be able to see what's going to happen. And I think one of the points that we try to sell is that actually you can use SolidCam as a testing ground. You can try a process, you can make sure that it's not going to collide, you can look at the time set, the cycle time. Then if you think, well, actually, maybe if I try this in a different way, you can then have a look and see whether or not you've made any time savings or whether it's, you know, it's better for the machine. And selling that concept of being able to trial it out and test it before you commit it to the machine. You know, all the time you're doing this, your machine's still producing parts and still making money for you. But you know, using SolidCam, you're then able to sort of run all these tests without any worries about it. So yeah, that's, you know, that's kind of where we see that the sliding head technology is going to sort of be beneficial. So yeah, it's good stuff.
It's a big strength for you, isn't it? Yeah.
Yeah, absolutely.
Yeah. Excellent, Ian. Well, you've covered some fantastic points here, and in particular the eye machining, you know, which is a super tool. And all I can say is thanks very much for joining us today, and I hope you enjoy the rest of the live webinar. Thank you.
Yeah, brilliant. Well, thank you very much for inviting us. It's great to work with you guys. So, you know, we look forward to when we can work together live rather than having to do it across webinars and stuff.
Absolutely. You know, I look forward to that day myself. And once again,
Excellent.
Thanks very much. And we do have a good team together. Thank you. Bye-bye.
All right, take care, Graham. Cheers.
Bye.
I hope you're all enjoying the event so far. So I just wanted to do a quick presentation on 5-axis in SolidCam and the barrel tool as well, show you how these have been programmed. So this toolpath here, we've selected the radius face and the two edges to blend between. The tool is a 6mm ball nose, and we're doing a 0.2mm step over. These are the only selections I've made, and we can see there that we get a nice sweeping toolpath. We can see that actually cutting there in the top left hand side as well. Nice sweeping toolpath around there. You can see that we are fully collision aware. Ball nose stops before it hits any of the vice or fixturing. Now the next toolpath is the barrel cutter. So here we select parallel cuts, we select the face we want to machine, and we want to wrap that around the y-axis. The tool is the barrel cutter that we're using today. This is a 250mm radius on the cutter, and the clearance plane is in the y direction. Now I'm going to put the sort into one way and climb, and on the tool axis control, instead of using angle, we're going to use the contact point of the barrel section. Now I'm going to set this to between 40 and 15%. That means that we're going to contact with the cutter between 40% around the barrel section down to 15% around the barrel section. I'm going to show you what I mean by that just in the basic simulation first of all. We can see here, if I just start the simulation and play that along, that first cut there, the contact point is 40% up along that barrel section. If I just speed that up, and as we go down the toolpath, the barrel tool will start to rock over, and if we just pause that there and get it to the top, you can see that we're a lot further down the barrel section on the contact point now. So now we're moving towards that 15%. So this is to stop us using the cutter in the same point all the time. We're varying the contact point, and we can vary that anywhere between 0 and 100%. So you can see there now we're getting a lot closer to the 15% mark as we get to the bottom of that toolpath. And we can see here in simulation the nice sweeping toolpath that we get as we contact around that outside shape. You can see that in the top left hand corner as well, actually cutting. So we'll hand back over now to Mike and Graham, and we'll see this actually cutting live on the machine, and you'll be able to see that barrel cutter create a nice finish along that face.
Hi and welcome back, and thank you very much to Ian Llewellyn for the interview, and hopefully catch up with you soon, Ian. Take care. So in the background at the moment, the 6mm ball nose is working its magic, but enough talk about balls. Let's get on to talking about the eliminator barrel tools. And going along with the flow of why compromise when you can customize. Why use a ball nose when you can use a barrel cutter? Because your time saving under certain applications can be absolutely phenomenal. I finished off earlier on talking about the ball nose. I'll let Mike talk about the barrel cutters for a little bit, and I'll come back in and speak about it myself. It's one of our favourite subjects, so over to you, Mike, for a bit. Cheers.
Thanks, Graham. Yeah. Well, absolutely. The barrel tool is a tremendous new idea, if you like, but it has been around for a few years really. But
yeah,
we've introduced it into is it 4 or 5 years?
4 years.
We've introduced it into the technical centre and into our program because we see it, and Eddie and Ross, as soon as it sort of was introduced to us, the idea was that this is going to revolutionise finishing techniques throughout the world. So Eliminator, we named it Eliminator because we're basically eliminating all opposition on this, because we're market leaders on these barrel tools. And what you've got to understand is, we'll go into it a little bit more detail. You'll see in the next screen, or a screen in the slide in a minute, where it shows the difference in step down from a barrel tool to a bull nose. So let's assume you've got a 10mm bull nose, 0.2 step down. You're getting a nice finish, but the cycle time is huge. You'd like to get a better cycle time with a increased step down. You can't. You're limited on the dynamics on the tool. So if you look on the screen, hopefully it's showing now, but you'll see that the barrel tool is based on basically a huge bull nose. So we use the radius of that tool to give us the step down increase. So whether it's 1 mil, 2 mil, 3 mil, 5, 6, it depends on what you're trying to achieve. So there's different versions of barrel tools, which Graham will go into, but I think the most important thing to say to you is that we develop the tools around the job. You're going to get fed up with this, so it's called infinite possibilities. Actually, you won't get fed up with it, because when you actually start buying into the process, you'll suddenly realise that there's huge savings to be made, cycle time savings. Now, one thing as well, as we love to always say, every tool we make with a view to be remanufactured. Recently, there was a batch of 200 barrel tools that went out to one of our customers in America, and they send them back on a regular basis for remanufacture. So we haven't actually got to the end of how many times that can be remanufactured, because they're working so well, and they're running in some difficult materials, in titanium as well. Do you want to talk a bit more about the different versions of barrel tools?
Is your throat going dry, Mike? Do you want me to take over for a minute? Yes, no problem at all. Yeah, we can talk about barrel tools all day long, but we've not got the time, I'm afraid. And we'll get a row for Ben for going over our time limit. The producer's very strict that we deal with. But anyway, here we go. Yes, barrel tools. Once again, Mike's probably gone over it again. We will manufacture a barrel cutter for any material, and again, like I was saying earlier, we have the geometry to suit the application and suit the right material. You'll hear people talking about conical barrel cutters. You'll hear them talking about tangential barrel cutters, and you'll hear people even talking about conventional barrel cutters, because barrel cutters have been around for a long time. There's just not been the software to drive them, and in this day and age we have SolidCam proving it out that the software is there now. It's a very complex software.
It's going in now.
Sorry?
It's going in now.
Yeah, it's coming in right now as I speak. What superb timing. Yeah, just shows it's live, and we're not just gimmicking it here, but the barrel cutter's coming in now. It's going to start whizzing about. Like I say, we do conical, tangential barrel cutters. Basically what I'm trying to say is, Quickgrind, if you've got an idea in your head, or whatever geometry a barrel cutter using, we can make any of them. We make them from our own software. You know, there's a standard range out there. There's so many people you'll see on social media at the moment who are chucking out barrel cutters, and they say, what's different about our barrel cutters? Well, the difference quite simply is, once again, and going back to infinite possibilities, we'll make any radius a barrel that you require. It is going to be a situation as we move forward with barrel cutting technology that is going to be almost bespoke to the part that you're producing, which will determine and drive the radius that you're going to apply to your application. And we've produced, I think, as small as 35 rads.
Yep. We've produced.
And we've gone up to, believe it or not, 10,000, which is almost impossible to calculate, but we did, and it worked. Which is almost a straight line, but there is a radius on it. The process for grinding a barrel cutter is very difficult. It's one of the most difficult processes within Quickgrind, but we master this, and that's what the challenges are for us. And we get it right, and we get the application right, and it goes out there. Time saving is absolutely astronomical. I've
Can you say
branched it
that?
already. But
Can you say that? Astronomical.
astronomical. That's not a swear word, is it?
No, you get away with that one.
Yeah, it's fantastic. You know, the time saving. You can get up to 90% saving on a barrel tool. And carry on, Mike. Yes.
Yeah, can I jump in there for a sec?
Yes,
'Cause
no
one of
problem,
the
mate.
things I think we want to say to you all is a little bit on from what Graham said earlier, is if you can use a barrel tool instead of a bull nose, then why not? So the question that I'd like to put to viewers is, ask us, can I use a barrel tool? I'm using a bull nose, I'm happy with the finish, or maybe not happy with the finish. I've got to improve cycle time. I'm stuck. How can I go? So with the right cam software, then you can drive this. That's the important thing. With the improvements in cam software, the barrel tool will be designed around your job. Obviously, we're running with SolidCam iMachining here. It's a tremendous way that we can prove to you some very, very good savings.
Yeah, absolutely.
And we do barrel tools. So maybe we do an F version barrel tool. We do a lens tool, which we're going to come onto in a bit. If you don't understand the principle, or we haven't really explained it too well, go onto our website, quickgrind.com. You can download the catalogues, which all of these tooling suits, tools we've shown you, these are just ranges that we are trying to highlight here. When someone says what range to do, we say it's infinite. You tell us, what are you trying to achieve, what tool do you want. If we can model it on the CAD, then we'll make it for you. One of the tools we had a gear that we had to look at, very small gear, 65 teeth. The tool had to be 1.8 diameter with a 0.8 bull nose on the end, and it worked tremendous. It's great. How are we doing in time? Are we nearly?
I think we're doing absolutely famously. And just to add a wee bit more in, we also have the lens tool as well, which basically is a radius on the bottom of an end mill, so to speak. It comes under the barrel tooling format. It comes under our eliminator range. We're also using it on the demo we're doing today, and likewise again your step over can be increased massively, resulting in a time saving once more. We could talk for hours and hours about barrel tooling. What we really need to do is get across the advantages of it. But moving on again, and talking about one of our other partners who have recently installed a surface checking system onto the Mazak, and that's a company called Bloom. And we're now going to go over to an interview I did a few weeks ago with David Mould from Bloom. He's going to talk a bit more about the system that's just been installed on the Mazak. Over to you, David. Thank you.
Good afternoon, David, and welcome to Quickgrind's live cutting event.
Oh, hi, Graham. Yeah, pleasure to be here. Thanks for inviting us.
Yeah, it's a pleasure to have you as well. You're one of our newest partners in the tech centre, and already you've made an impact. And I do believe at this moment in time we have a new system getting installed on our Mazak G500. So I take it that's what you're bringing to the table in the live cutting event. So could you explain a bit more about the process that's going on in the machine at them just now? Thank you.
Yeah, certainly. A pleasure to. We're actually installing it as we speak, so hot off the press on this one, with our very latest technology, really. I think people who know Bloom know that we came out with the Digilog family of products a fair few years ago now, and there's been new adaptations to that product as time has gone on. To briefly explain, the Digilog is taking conventional probing, so touch probing for part inspection, part setup, but it also brings an analog aspect to it, so we can start to do scanning of the part for free-form components, 5-axis components, and we can actually do full measurement on the machine. Right. But the system that we're currently installing now on your Mazak in your showroom there is the latest generation of the digital products called the roughness gauge, the TC64RG. And it's a spindle probe that is designed for surface measurement, so measuring the surface integrity and quality inside the machine tool while the component is still clamped. So what we have and what people will see there on the Mazak is that there's a spindle probe. It looks like a conventional spindle probe held in the machine tool spindle and loaded in through the tool change. But when we drag across the surface, we're actually measuring the surface quality of the component. And then with the external software, the Bloom RG version 3 software is doing then an analysis, and it gives you the results of the surface finish in all the conventional measurement protocols, so RA, RZ, RT, RMAX, RMIN. You'll get all those results displayed across the screen, which people will be able to see. So a customer can instantly get the result in the format that they prefer, that they would normally measure their parts with. So yeah, it's the very latest technology from Bloom.
Yeah, that's excellent, and thank you for explaining that. And we're very grateful that it's getting installed onto the machine. You know, it's another advancement for us, something we can talk about. I'm sure in the future we'll probably do more events like this and involving yourself, going more in depth into how it's being used. From Bloom yourselves, the door's open. You're back in action after everything that's been happening over the last few months in the mayhem. Are people okay to come in and see you and get a look around the facility in the showroom?
Absolutely, yeah. I mean, these crazy times we live in, but yeah, we didn't stop. We stayed open, although
very good.
A lot of the time was a lot restricted and not many people wanted to travel about really. But yeah, we've set up the facility that we have here in Burton, and so we comply with all the government guidelines and laws of the way we have to work these days. And we're open. Our guys are active. We can come and visit customers, talk about projects, or customers are more than happy to come here and see, what we're about, what we can do. Obviously, facilities like you guys have got there, that excellent facility that you've got there is perfect for us to be able to show products, live demonstrations, and customers can really get their hands on and really feel what it's like. So yeah, fully operational and ready to talk to anyone that wants to talk to us.
Brilliant. What you just said there, I mean, about our facility being open and being able to use it, and like I say, hopefully in the future, we do have a lot more engagement, and you can boost your product and get a bit more profile in it. We are always open for any type of event like this, and you're already, like I said, you've been a fantastic impact to us.
Super.
But yeah, it's absolutely brilliant that you're getting involved in this event today, and we value your time and greatly, and thank you very, very much for getting involved in the event today, and hopefully there's more to come in the future. Thank you very much, David.
Super. Appreciate it.
Yeah, and hopefully in the not too distant future we'll be able to meet face to face as normal. Thank you very much. Cheers.
Cheers. Thank you.
Hi, welcome back again, and thank you very much to David for your input. It's you're a valued partner within the company, and we really appreciate it. And we've another quick question in here, just a heads up for Quickgrind. It says, it's great to see you guys having such enthusiasm in barrel cutters, and Graham looks like he also enjoys a barrel of beer now and again. I forget, that's a bit harsh as well, I think.
Well, it's true though, isn't it?
Well, that's true, aye, absolutely. Anyway, over to Mike to talk a bit more on this fantastic barrel tools. Cheers.
And of course I don't drink ale, so...
You don't drink, Mike, you stop now. No. You've been all sensible.
So the thing with the barrel tool, which perhaps we haven't talked about in too much detail, is applications. It is an application-specific tool. It's if you've got it in your arsenal with the right CAM software, then it will be invalid. And once you've got used to it and understood it, and obviously you can come to the factory here. We'll demonstrate it live to you. We can look at you could possibly send your components to us. If we can put it on the Mazak and hold it, then we can replicate that to you. That's something that we offer through John Butler and Charlie, through the applications managers. So one of the things is to how to think about where to use a barrel tool. So let's go back again. If you're scanning with a bull nose and your cycle time is taking a long time, but you're getting a great finish, you want to improve your cycle time, think about a barrel tool. It's probably as simple as that. We're going to talk about lens tools in a second as well. You can look at some of the mold and die industry and mold tools and deep pockets where the barrel tool will come in. What we like to do is have as stubby tool as possible. We change the tapers and the radiuses, flute radiuses, ball noses to suit the application. You can have 2 flute. We've done 2 flute. We've done 8 flute. At the moment, the sky's the limit still. I don't think we've even touched on the limits of what we can do.
Just to quickly come in, I mean, it's also a multi-purpose tool as well.
The way it is.
Having a ball on the end of it as well, so you can get into a pocket and do all the barrel work and fill up the walls as well. So it's such a versatile and fantastic tool to use. But now I think we're going to go and talk about
the lens tool, which
the lens tools.
You mentioned earlier, but
yes, I was a bit too quick mentioning them earlier. I was going ahead of the slides, so apologise for that. I'm not a professional, so back over to you,
You
Mike.
told me you were. Oh God.
So as we were saying earlier on, lens tools, and we can go on again about the different rads, and you can have whatever rad you fancy. They're a very, very good tool for surface area. If you can imagine scanning with a ball nose, 0.2 over a surface, and then applying the lens tool with the size of rad that it's got on it. It could be 12, 18, 20, 25. Some of them bigger, but we tend to work within that. There is a lens tool being used on this part as we speak. There's another component sitting over the front that solid cam used with a lens tool, and they also with the part that's sitting in front of it, we manufactured the tool, which was an idea of Ben Miller, can we use it as an end mill as well. So we went up the flute, put the radius on it, so we went up the leg of the brake hub, formed the radius, and then finished off all around the part. So it was actually a 1 in 3 tool. So thank you for the input in that one, Ben. And we've actually applied that in different processes with different customers and different applications. So once again, the versatility of the lens tool is fantastic. Time saving is huge. And in the game out there, where especially manufacturing plants throughout the country, throughout the world, every second counts and every second's a penny. So we stress massively to customers how good this cutting tool is, and how good the barrel tool and encompassing the lens tooling process is to our business, and also to your business. Anything else to add, Mike?
Well, probably going to add to that is we see this such an important tool for us that we have a website dedicated to it. That's barreltools.com. It's live. It's now. It's you can go and have a look. You can download the brochure, the Eliminator brochure, and then if you open up the brochure and then you go, I don't know what the range is. Let's go back to what we always say: infinite possibilities, especially with barrel tools of all the different versions. We'll design it for your job. Because it's feature specific, you do need to talk to us. It's a lot better to talk to us. Just give us a bit of time. So if you say, I've got a job running tomorrow, I want to run a barrel tool, probably not the way we do it, and the best way to do it. If you say, I've got a job running in 3 days' time, I need a bell tool for it, chances are we could do it for you. The important thing is to get the right strategy. We'll design a tool, you tell us what you want to do, job's a good one. Everyone's a winner in that respect. So yeah, go on to barreltools.com. There's going to be videos and all sorts posted on there throughout. This isn't going away. This is getting bigger and bigger. We have inquiries from all around the world about these tools. There's lots of interest. So we're really pleased. We've invested a lot of time, a lot of effort, and a lot of money into delivering these, and we're pretty good already.
Yeah, we absolutely are. You know. Like I say, we can keep going on about it, and we do want to keep going on about it because it's a huge part of our business. But the proof's in the pudding. You know, try it, speak to us, and we'll come in and throw our technical ability against it, and we'll get results. And so, moving on now. You know, we've got another interview. I've caught up with Scott Ravenscroft from CG Tech VeriCup. I think during the lockdown, Scott's been down the gym because he's lost a bit of weight and he's looking as fit as a butcher's. So well done, Scott. So over to Scott's interview, and thank you for your time, Scott, as well. So catch up with you again soon. Cheers.
Good afternoon, Scott.
How you doing, Graham? Okay.
I'm very good, and thank you very much for joining us on the Quickgrind live cutting event.
No problem at all, and thank you for allowing us to be part of your event today, Graham. We're very much looking forward to it.
Yeah, and thank you for giving up the time to come and join us this afternoon. Your support's absolutely fantastic. As you know, you've as a partnership, you supported us very well over the last few years. But I was wondering if you could maybe elaborate a bit more on what your software actually does. Tell us a bit more about VeriCup in general.
Yeah, so thanks, Graham. Firstly, I'd like to speak a bit about how we've actually supported you with your event this afternoon. Obviously, SolidCam, you're working in conjunction with SolidCam and ourselves. Now, SolidCam are based in the north of England, and your tech centre is obviously based in the south of England, or southwest of England. So obviously, SolidCam are doing the programming for the component.
Yeah.
I don't know how much of a proven post-processor they've got for your Mazak. So what really it's allowed SolidCam to do is run the G-code through VeriCup as it would run on a machine tool, and you know, that's indeed about what VeriCup's all about. VeriCup will run the same G-code through the simulation as it would run on your machine tool. So thus it allows SolidCam specifically for your event to be able to prove out their process offline before they come on site. So when they do eventually come on site to prove, or when they came on site to prove out the program, they already knew the G-code was good, safe, minimal amount of time in proving out the job, because again, the benefits of VeriCup is you can take all that prove out offline and do that all through the software. So in a nutshell, Graham, what is VeriCup doing for the event? Independently proving out the same G-code that your Mazak machine tool runs. And that's indeed what SolidCam have done for your event today.
You know, just taking out of that what you've just said there, Scott, it obviously gives your customer base a lot of confidence in using the VeriCup product when they can pretty much go to the machine knowing that they're not going to have any collision. Am I right in saying that? Yeah.
Yeah, that's the whole objective of the software. Yeah, the objective of the software: safe program, right first time every time, and to minimise downtime in terms of prove out at the machine tool. And indeed, in most cases, there'll be no prove out whatsoever. They know the program's good before they actually take it to the machine tool to run.
Right. Obviously, you've got a lot involved in your software. You know, it's a very powerful system. From my point of view, you know, I've been involved in and attended some force events, which I found very, very enlightening. I know it's a bit of a buzz for yourself. You're always improving it. Every time I've been to one, something else has been added on, and it's always very, very interesting. Could you maybe tell us a bit more about the force product?
Yeah, sure. So we launched Force to the UK market probably getting on towards 4 to 5 years ago now, Graham. It was a bit of a slog at first. It was, you know, with any new technology, I guess customers and prospects are a bit sceptical of new technologies. So we did a lot of hard work in the early days, and to some degree are still doing hard work proving the technology. But we're getting there with it, and we're seeing more and more customers adopt the Force module. And essentially what Force is going to do for you is look at an existing process, really importantly against the characteristics of the material you're actually machining, so it's physics-based software. It will map the process out for you in graph form, so you're getting a calculation of chip thickness on the tool, and you're getting a calculation of force. And what we want to do is look at that chip thickness and vary motion in the NC program to flatten out that chip thickness, get a nice balanced NC program to maximize the cutting conditions safely. So and what you're seeing with the product now is, obviously, as I said, we launched the product to the UK 4 years ago. It's a relatively new piece of software, then becoming maturer and maturer. There's more and more gone into the software, mostly for ease of use. So what specifically for 9.1, Vericut 9.1, is that we've actually introduced what we call Force Learn mode.
Right.
So we can look at the process. Prior to Vericut 9.1, the user would have had to click on the graph, get a reading. I want to populate that limit at that particular point. Well, Force can actually learn from them results now and populate all the limits into the software without very little user interaction, 1 or 2 mouse clicks, and you get an optimized process at the end. And that's what we've done and worked very hard on over the last year or so developing to bring that benefit to the software.
Yeah, well, from my point of view, it not only improves cycle time, also tool life, and it's a benefit to the machine tool life as well, which I find is a rounded package is absolutely fantastic.
So you're not going to just get a reduced cycle time. If we think about what damages carbide, it's shocks on the carbide, it's spikes in the process, and that's what's you're going to identify with Force. Is have you got any bad motion in your NC program which is going to damage the carbide? So it's not all about cycle time, it's about a more cost-efficient process in terms of reducing your consumable spend as well.
Really interesting, Scott. Thanks very much. You did touch on it previously about your customer base. How does Vericut go out there in the field and support the customer base?
Really, really important. Really good question, Graham, and very, very important to us, and something we're very, very proud of, in fact, is the level of service and support that we can provide to our customer base. So, I mean, I've worked in the software industry quite a long time now, Graham, and prior, you know, what will customers typically be used to? Well, sometimes you may pick up the phone, you want to talk to an engineer directly at that moment in time. Well, yes, CG Tech absolutely can offer that service. So if I was to dial the support line now and I want to talk to an engineer right now, I can do that. And I can then ask that engineer to remote into my system there and then to have a look at that particular problem you're having at that moment in time there and then. So it's about giving the customer a high level of service. We're not interested in putting them into like a ticketing system or a queue for an engineer to call them back. That's not good service. That's not what an end user wants. And also speed of turnaround in terms of customer buys a new machine, the machine tool's delivered. They want that Vericut machine configuration delivered pretty quickly, and we can obviously we can offer that service as well. So we do pride ourselves on the service we offer our end users.
Well, you certainly assist us greatly, Scott, and hope that wasn't too much of an endurance test for you. And I'd just like to say thank you very, very much for being part of this live fitting event with Quickgrind today. We value your support greatly. hopefully very soon we can have a proper face-to-face instead of sitting on a screen. And it's always a pleasure talking to you. Thank you very much, Scott.
Thanks again, Graham, for inviting us. Thanks very much.
Not a problem at all. You take care.
Hi, and welcome back, and thank you very much to Scott for your valuable time. Very much appreciated, and once again another very valid partner within the tech centre at Quickgrind. And I'll pass you over to Mike now. He's going to. Have you got another question?
Yeah, we've got a question.
Oh, very good. There we go.
Question from someone called Carl in the USA. He's asked can he get barrel tools over there, and the answer is yes, you can, Carl. We do, as I said before, we deal worldwide. We have a very slick operation that allows us to supply tools quickly. If you go on our website, you'll explain it in more detail. But it's the same process. We'll discuss with you online. We can have a Zoom meeting. We can discuss the part, what you're trying to achieve, where you are now, where you want to go, where you want to get to. So not a problem, you know. As long as we can ship to you, basically, we'll supply you. So thank you, Carl, for that. We wanted to just say to you a little bit about the slides. So the slides we're showing today are based around new brochures that we've got out and available from the website. These are only highlighting certain ranges of tooling that we do. There's a lot more brochures coming out, but don't think that's all we do. You know, it's Graham mentioned before, T-slots, Woodruff's T-slots.
Yep.
Well, you basically name it, we'll do it. I think, again, as Graham said before, they'll be tailor-made for the application.
Woodruff's
as we go on, yeah. So
yeah.
Go on, mate.
Woodruff's dovetails.
Yeah.
Yeah. We have any kind of special, you know. We can do the Christmas tree cutters as well, which you're a bit more.
We've done a few of them.
And we also do which Michael briefly tell you about on the clay machining as well. So we're fantastic range that we've got. Yeah.
Yeah. Well, clay machining, you know, it's for the automotive. Well, not just automotive, but the design industry. There's studios around the world now using our specifically designed tools for machining the clay models.
Yeah.
It's you'd think it'd be an easy thing to do, but it's a hard wearing material. It is easy to clog, so what we had to do on that was produce some tools which have a very high slip capability, low coefficient friction on the coating, but also a very sharp tool. One of the first customers we developed it with was getting one or two full model cars from a tool. If he was lucky, often it would jam and stick on the tool. So with working with them, we developed it, and he happily gets between 5 and 6 full-size cars machined with it, from anything from 20 mil down to 2 mil. We do very filigree little door insets on things like that. The tools now are fully balanced as well, which is another addition which we've added to the tech centre. So balance tooling is something we do if requested.
Yeah.
I think you just ask us. If we can't do it, we'll work out a way to do it.
Yeah. The reason why I threw that question over to Mike about the clay machining is I've not got any customers that use it, so Mike knows a lot more about it than I do. But like I said, all through this we've worked as a team, and it just emphasises what diversities that Quickgrind can go to in manufacturing something out of solid carbide rod. We've been at it for a very, very long time. We like to think we're the best at it. That's the way we go out and portray ourselves. And we'll talk a bit more after the next event. But moving swiftly on, one of SolidCam's very strong fields is SolidCam Swiss, which in machine shop terminology is sliding head technology. SolidCam are very, very strong in this, and they've got fantastic software. So we're going to get a bit of a demo from Mark from Swisscam on the Swiss technology. Okay, over to you, Mark. Thank you.
SolidCam support for Swiss Turn is both comprehensive and simple to use. In this overview, we will be demonstrating this on a Citizen M32 machine. This machine is a 3-channel machine with 5-axis capabilities, multiple machining patterns and superimposition. All of these features are fully supported in SolidCam with full machine simulation. SolidCam supports all tool holder types, including multi-station tool holders for both milling and turning tools. Tools can be moved to different stations and dynamically viewed to make sure the tools are set to the optimum position. Programming of operations is exactly the same as it would be for any mill turn machine in SolidCam. Here we are selecting the area to turn directly from the model and the tool from the library. The tool path is then calculated with full support of cycles on the machine. As with all operations, this can be viewed and simulated as the machine will cut it. Even adding more complex machining strategies such as cylindrical milling is kept simple. Select the area to machine direct from the model, the tool, and SolidCam does the rest. Once the programming is complete, the channels can be optimized to get the best cycle time on the machine. Currently the part is programmed as a single part, but in reality we want to be working simultaneously on both spindles. This is done by selecting the operation to start machining on the second spindle. Now we can see the operations working together in all 3 channels. Based on this, SolidCam will automatically choose appropriate machining patterns which can be reviewed and changed by the programmer, as in some cases alternate patterns are available. The programmer has full control over the positioning of the weight codes, and SolidCam will assist this by dynamically checking and advising any issues. Now the complete program can be simulated as it would be cut on the machine with all axes working together. This highlights any potential collisions and will show any superimposition moves programmed, giving confidence the program is correct before being passed to the machine. This can significantly reduce machine downtime. Once this has been proven successfully, the G-code can be created in a single click, and here we see the result displayed in our SyncMaster software, clearly displaying weight marks and axis patterns. SolidCam is available for all Swiss machines. For more information, please go to solidcam.com.
What we're also going to do now, once Graham's finished, we're going to talk about just a few more aspects to our overall range and services that we do. One we want to talk about, next slide, is the Orbis range. Orbis is a lollipop cutter range. Lots of lollipop users tend to just use it for undercuts or deburring. With the latest software now we're looking at tube milling, so we're looking at manifolds especially. What we're doing here is we producing different geometries to suit different materials, so aluminium, and then another one for titanium, another one for steel, and then overall, if you download this brochure from our website, you'll see that there's an option, because there's basically we'll design it for what you want. Graham's got a customer who's happily machining peak with them, and getting tremendous finishes and results from that, and that's not just an easy material, really, is it, that one?
Yeah, absolutely is. The peak material can be quite aggressive. It's abrasive material, and once again we applied the correct geometry and the correct coating in the TX Plus. Nothing else was really working, but I think prior to that, the lollipops that our customer had been using, there wasn't much development in them. And we keep saying it, and we keep talking about infinite possibilities. We apply a process through every single item that we do. You could look in a catalogue and see hundreds of lollipops, all different sizes now, but they're all pretty much the one geometry. We make the lollipop to suit the process. It's again, we'll do the geometry for aluminium through steels, through stainless steels, through exotics, you know, carbon fibers, you know, the composites, anything through that. And you have to get the ball right. You have to get the neck behind it correct. When you're using softwares as complex as SolidCam, they can manipulate the system to almost machine 90 degrees when we're doing a tube. For instance, on a manifold on a Autosport, like, or an F1, and it almost looks like an impossible machine. You can maintain a diameter, you can contain a consistency, and you can contain a machine part. So you're not having to rely on polishing or casting. You apply the lollipop. Again, it's down to about the finish that you want. If you want to just rough through it, you know, you put in a big step over. If you want to get a mirror finish, you put in a tiny step over. An advantage of our lollipops as well, we put the geometry completely around the spherical machining side of it. So you can actually drag machine as well with it. So when you're machining, it sounds like it's the wrong type of process and it's going against engineering, you know, philosophy. But if you drag machine with a lollipop, you know, you can pull it back up the other side of the tube, and it works perfectly. The finish is absolutely fantastic. So the versatility that we put into our lollipops is we like to think we put a lot more thought into it than our competitors, and people come to us with more and more complex parts, more and more difficult parts. Automotive industry, the aerospace and medical industry are coming to us with all different sorts of materials, and they're throwing these problems at us, and we solve them, and we make the cutter, again, the right cutter for the right application, and we follow through it this whole live event that we've done. It's infinite possibilities, and that's what we want you to use us for.
I'm sold on it. So we also want to just show you a few more slides here. One here is QuickCam. QuickCam is our application model, if you like, where John Butler is our applications manager, and you can see on the slide there, you know, as we are the restrictions of visiting places, there's a virtual engineering capability that we can have where we can discuss your particular application with it. As the brochure will see, if you download the brochure, it's toolpath optimization, there's programming solutions, it's developing the tooling around those applications that you need. It's a complete tooling process. So please do contact John, or if, obviously contact the contact at quickgrind.com. Is that right? And then
You'll get there.
We'll be happy to. I'm tired now. We're happy to discuss all this with you. The next slide is the Quickgrind Technology Centre. That's where we are. It's it's a lovely shame we couldn't show it around. But if you go onto MTD CNC, we've done a lot of interviews and a lot of
nice wee dig for them there, Michael.
Oh yeah, that was great, wasn't it? Almost think I knew what I'm talking about. We did a Swarf and Chips with them, so a takeover, Swarf and Chips takeover, and I brought people around the factory, walked you the camera around the factory, discussing where we are and everything about the factory. So have a look on that. You know, the guys from MTD have done a fantastic job for us over the years. You will, when you do come and see us, and please come and see us, keep saying that, but we'll show you the technology centre, and we've got training rooms upstairs, which you know you can really use as well.
Come
All
and
our
use
partners
it. Yeah.
can do that.
More than welcome.
Probably the next thing next slide we're going to talk about is the Quick Edge. We had a question from James. Hi James. He asked about how many regrinds can we get from a tool. It's in some ways it's infinite again. Isn't
it's infinite again. I mean we can get up to on our taper tools. There's some of our customers, especially the overseas customers, have had up to 20 remanufacturers. We don't call them regrinds. Naughty boy, Mike. It's a remanufacture. It's for me to pick you up on. Well done. Yes. When we say remanufacture, folk think we're a bit snobby about it, and they say, "Oh, you mean a regrind?" And no, it's a remanufacture. We remanufacture every process, every piece of geometry, down to and sending it away for coating. It's not just to lick up the flutes, it's not just a wee end grind, we remanufacture everything. So what you're actually getting back is a brand new tool every time. So when I say we can remanufacture 20 times, every time that tool comes back to you, the only thing that's really changed is the length. And that's where the restriction is, when it gets too short to be able to apply it into your programming. So it is a remanufacture. Customers use us, and we send them back, and they run them like for like. Put the cutter back in at the same data that they've been using prior to it, and they get a result. So we call it remanufacture because it absolutely is remanufacture. And again, for the people that are watching, and potential customers and customers we're having board, it's a testament for them to say there's a massive saving again. So we can go through a process with you, and we can guarantee you within 6 months to a year, if you buy into remanufacture, you're absolutely saving money. So that's all.
And of course, it's not just our own tools. We're happy to take other kind of tools, especially as a big process we have at the moment with drills.
Yeah, we'll remanufacture anybody's tools. They don't like it, but we do. Drills as well, so we can remanufacture them. But
there's some big investment recently on long series drills, 30, 40, 50. So we've put a new P-axis on so that we can keep the tool stable. So that's another thing you can. We can regrind for you, and of course we can make you the new tools, new drills as well.
Well, Mike, I think we've
got a couple more. Look, vending.
Coming towards the vending now, which is how we drive our stock around the world. We're vending in probably all the countries, virtually every country that we deal with, we've got vending. It's very good for your stock control. It helps you with your ISO standardizations as well when you're looking down that route, because it trims everything down, and you have a system in place that is controllable. Everything's controlled from Tewkesbury. We don't have any other facility throughout the world. Everything that gets vended. So if a cutter gets vended in Chile or Brazil or in Italy, we see it on our screens. It's a fantastic setup. It's our own setup. We built the software for it. So it's something that we're very proud of, and it's also a system that we sell throughout the country as well. So you can buy into the vending side and the remanufacturing side and stick it all in one of our vends and have it on site. So you get next minute delivery, not next day delivery.
Yeah, absolutely right. Perfect.
The end.
We have come to the end.
And that's pretty much the end, folks. And all we can say is thank you very, very much for attending. We really appreciate it. Thank you very much to all our partners. And a big thank you to the man behind the scenes here who's done everything, Ben Miller. He's sat there all day. He's not in the picture, and he's made all this work.
Done a brilliant job. Excellent.
Thank you very much, Ben, and thank you to Charlie as well, our applications engineer. And once again, from the both of us, thank you very much.
See you soon.
Take care. We'll see you again soon. Bye-bye.
Be safe.